స్లైడ్ షో ఇక్కడ. Good evening and welcome to my classroom. Let us get started. Sigma r is equal to 0 to n NCR cos Rx. Let us see. We can write this as sigma r is equal to 0 to n NCR into cos Rx. So we shall write this as the real part of sigma r is equal to 0 to n NCR into cos Rx plus I sin Rx. So we can write this as the real part of, because cos Rx is just the real part. So the real part of sigma r is equal to 0 to n NCR into e to the power of I Rx. So this is the real part of sigma r is equal to 0 to n NCR into e power ix whole power r. So which is nothing but the real part of 1 plus e power ix whole power n. Sigma NCR extra power of r is 1 plus x whole power n. So because of that, this becomes the expansion of 1 plus e power ix whole power n. So this is the real part of 1 plus cos x plus I sin x whole power n, which is the real part of 1 plus cos x is 2 cos square x by 2 plus I into 2 sin x by 2 cos x by 2. So whole power n. So we shall pull out 2 cos x by 2, which becomes 2 power n cos power n x by 2 into the real part of cos x by 2 plus I sin x by 2 whole power n. So therefore by De Moivre's theorem, we can write this as 2 power n cos power n x by 2 into the real part of cos nx by 2 plus I sin nx by 2. So therefore the real part of this is only this part. So this is 2 power n cos power n x by 2 cos nx by 2. So this is required result, 2 power n cos power n x by 2 cos nx by 2. So this is the required answer. Yeah. All right, we shall now move on to the next problem. The value of 62 into the continuous product of zi plus 1 by 2 zi minus 1, where zi are the roots of z power 5 minus 1 is equal to 0. All right. So 62 we can take care of later. So here I is equal to 1 to 5 zi plus 1 by 2 zi minus 1. 2 zi minus 1. Now you see, for the polynomial z power equation z power 5 minus 1 is equal to 0, z1, z2, z3, z4, z5 are the roots. Z5, these are the roots. You can notice, if you consider a polynomial equation, a extra power of 5 plus b extra power of 4 plus c x cube plus dx square plus ex plus f is equal to 0. You have Vieta's theorem, some of the roots, some of the products of the roots taken 2 at a time, some of the products of the roots taken 3 at a time, some of the products of the roots taken 4 at a time, and then the product of the roots. So all that, because z power 4, z cube, z square and z, those terms are missing. So you have only z1, z2, z3, z4, z5. Product of the roots is only available. So it is sum of the roots is minus b by a, next is positive, next is negative, next is positive, next is negative. So that is minus c by a, so that becomes 1 basically. So this is the value that we have, and apart from that, any product of the roots in whatever the combination is actually 0. So this is z1 plus 1 into z2 plus 1 into z3 plus 1 into z4 plus 1 into z5 plus 1 by 2z1 minus 1 into 2z2 minus 1 into 2z3 minus 1 into 2z4 minus 1 into 2z5 minus 1. So if you consider this, here z1, z2, z3, z4, z5, that product is 1, and all other products are becoming zeros because z power 4, z cube, z square, z, those terms are not there here. So therefore, all other terms will become 0, and 1, 1, 1 multiplied by 1, so that is 1. So that remains. And in the denominator also same thing here. 2z1, 2z2, 2z3, 2z4, 2z5, when you multiply them, you get 2 power 5, which is 32, z1, z2, z3, z4, z5, which is 1, and all other products, all other sum of the products will become 0, and minus 1 multiplied 5 times, I get minus 1. So what I get is 2 by 32 minus 1, 2 by 31. So to get one integer type of answer, the question has been written like this. So it is 62 multiplied by 2 by 31, which makes it 4. So the required answer is 4. So hope that is understood. All right. So let us move on to the next problem. Let alpha power k, nice problem. Let alpha power k, k is equal to 0, 1, 2, 3, etc., 20, 21, with the roots of x power 20, 22 is equal to 1. Let there exist a root alpha power r among alpha among these roots, which is denoted by xi, such that xi power k, where k is equal to 0, 1, 2, 3, etc., 20, 21, are also the roots of x power 20, 22 is equal to 1. Find the number of values that are possible for r, one integer answer problem. So here we are talking about primitive nth roots of unity. We are talking about primitive nth roots of unity. Now, what exactly is primitive nth roots of unity? You must be knowing already. I'll just tell the point quickly and move on to solve the problem. What is primitive nth root of unity? See, when you consider nth roots as 1 alpha, alpha square, alpha cube, etc., alpha power n minus 1, in this you see alpha, if you square it, you are getting alpha square. If you are cubing it, you are getting alpha cube. Raise it to the power 4, you are getting alpha power 4, etc. So alpha has the capability to bring out all the other roots by appropriately raising it to a certain power. So alpha, by raising it to the power 2, raising it to the power 3, raising it to the power 4, etc., we can produce all the other roots. We can generate all the other roots. All right. So now what is primitive nth root of unity? The question is alpha the only one which has this capability? It's not just only alpha. There could be other roots which also will have the same capability of generating other roots. So the concept here is, it is obtained as follows, like this. You see, 2022, think of its prime factorization. 2 into 1011, which is 2 into 3 into 337. 337 in this case is also a prime number. All right. So the prime factorization of the given number 2022 is 2 into 3 into 337. So then the number of numbers which are less than n and prime to n, the number of numbers which are less than n, the number of numbers which are less than n, and prime to less than n, one second, and prime to n is, you know this, it is phi n is equal to n into 1 minus 1 by p1 into 1 minus 1 by p2 into 1 minus 1 by p3 and so on. So in this case, it is n is what? 2022 multiplied by 1 minus p1, the factors, prime factors. 1 minus 2 is a factor, 3 is a prime factor, and 337 is a prime factor. So this value is phi n is equal to 2022 into 1 by 2 into 2 by 3 into 337 minus 1, 336 by 337. All right. So this is comfortable here for cancellation. What we are getting is 336. So there are 336 numbers which are less than 2022 and are also prime to 2022. So those are all the, so alpha power k, where k is equal to those values, are all primitive nth roots of unity, meaning they all behave like alpha itself. So each one of them, if you take, square them, cube them, raise it to the power 4, they can generate all the other roots. 336 of them out of the total 2022 roots, out of them 336 roots have the capability to generate all the roots. So they are called primitive nth roots of unity. So the answer is 336. The number of values that are possible for R. So the number of values that are possible for R is 336. So this is the thing. The concept of primitive nth roots of unity must be known to you already. It's good to revise it once. All right, we shall move on to the next problem. Let E be the set of all complex numbers Z which satisfy the condition, mod of Z minus 2 plus I less than or equal to 1. Let for any complex number Z not equal to 0, arg Z denote the principal value of the argument, then which of the following is or are correct? Let us see. So here, mod of Z minus of 2 minus I less than or equal to 1. So this represents a circle, the region inside the circle and also on the perimeter of the circle, with the center where 2 comma minus 1, center at 2 comma minus 1 and radius 1 unit. All right. So you have circle like this. Two comma minus 1. All right. So now I'll write little All right. This doesn't look like a straight line. So that's the issue. All right, we'll adjust with that. So now we have to look into these options, maximum value of mod z, etc. So z can be anywhere within this circle, center at 2 comma minus 1 and radius 1 unit. And now all right, we maximum value of mod z and minimum value of mod z. Here one of them is maximum and one of them is minimum. Let us see. This could be minimum. All right. Let me also draw this line. Now, mod z z can be anywhere on the circle. Mod z will be minimum when z is here, right? Because the distance from mod z means distance from 0, 0 to the point, variable point, moving point z. So when z is here, mod z will be minimum. So this distance from here to here, this distance is root of 2 minus 0 whole square plus minus 1 minus 0 whole square. So this distance is totally root 5 and minus the radius is 1. So root 5 minus 1 is the minimum value of mod z. So minimum value of mod z, here make it minimum here. Minimum value of mod z is root 5 minus 1. Root 5 minus 1. So this is correct. Next, maximum value of mod z. When you want maximum value of mod z, you see when z is here, you get the maximum value, and that maximum value is, this is root 5 anyway. From here to here it is root 5 and the radius is 1 unit. So root 5 plus 1 will become the maximum value. That happens when z comes here. Root 5 plus 1, yeah. Next, minimum value of arc z and maximum value of arc z. Okay, you write this as maximum. Please make small changes in the question itself. Here you write it maximum, here you write it as minimum. Okay, everything else is fine. So here maximum value of arc z, is 0 because when z is here, argument will be maximum, which is 0. So this is maximum, and when z is here, the argument will be minimum. So this value we have to find out. To find out this value, we shall use the circles concepts. So what shall we do? We shall find the combined equation of tangents. After all, x-axis is one tangent and this line is also one tangent. So the combined equation of tangents drawn from the point 0, 0. So to find the combined equation of tangents drawn to the given circle from 0, 0. For that, let us write the equation of circle first. So equation of the circle is x minus 2 whole square plus y plus 1 whole square is equal to radius is 1 square. So this is x square plus 4 minus 4x plus y square plus 1 plus 2y is equal to 1. So we have x square plus y square minus 4x plus 2y. I'll write it a little. That has to come this. Yeah, x square plus y square minus 4x plus 2y plus 4 is equal to 0. This is the equation of the circle. Now, S1, where the point under consideration is 0, 0, will be S1 will be 0, 0 minus 2 into x plus x1. X1 is 0 plus y plus y1 is 0 plus 4. This is S1. Now S11 will be x equal to 0, y is equal to 0. If I get S11 as 4. Now combined equation of tangents is S into S11 is equal to S1 square. So S11 is 4 into S is x square plus y square minus 4x plus 2y plus 4 is equal to S1 square is minus 2x plus y plus 4 is equal to 0. Whole square. So this is 4. I'll do a little simplification here. 4x square plus 4y square minus 16x plus 8y plus 16 is equal to 4x square plus y square plus 16 minus 4xy plus 60 plus 8y and minus 16x. Let me check once. So I have 4x square plus 4y square minus 16x plus 8y plus 16 is equal to 4x square plus y square plus 16 minus 4xy plus 8y minus 16x. All right, few things will get cancelled. So here 4x square is gone and we have 4y square minus y square is 3y square and you see minus 16x is getting cancelled, 8y is also getting cancelled and we have minus 4xy, this 16 also is getting cancelled. That minus 4xy will come this side as plus 4xy is equal to 0. So this is y into 3y plus 4x is equal to 0. So out from this y is equal to 0 is one tangent and y is equal to minus 4x by 3 is another tangent. You can see here y is equal to 0, of course the x-axis is one tangent and y is equal to minus 4x by 3, that is this line and therefore arc of minimum value of argument is the slope of this line. Basically the slope of this line is minus 4 by 3. So arc Z minimum value of arc Z minimum value of arc Z minimum will be minus tan inverse 4 by 3, right? So this is the minimum value of arc Z. So arc Z can be anywhere on this plane. Once again on this disc, this is the disc and the locus of Z is this disc. Now if Z is here, arc Z will be maximum and when Z is here, arc Z will have minimum and that minimum value of arc Z is minus tan inverse 4 by 3. So here what you can see, all the 4 options are correct. So this is the problem. All right. Let us move on to the next problem. Let alpha be a non-real root of z. It's an interesting question. Let alpha be a non-real root of z power 5. Let alpha be a non-real root of z power 5 is equal to 1, and let fx is equal to a polynomial 7x power 5 plus 4x cube plus 5x square plus 3x plus 2. Then the value of sigma k is equal to 1 to 5, f of 1 by alpha power k. An excellent question this also. See here, one interesting result which you must be knowing already. The result is this. Suppose alpha is a root of let us say z power n is equal to 1, all right, nth root of unity. And let us say we are given a polynomial, and let fx is equal to an extra power of n plus an minus 1 extra power of n minus 1 plus an minus 2 extra power of n minus 2 and so on plus a naught. All right. Now, if we want the value of sigma, sigma k is equal to 1 to n f of 1 by alpha power k. If this is required, it is n into a n plus a naught, a n plus a naught. So it is simply a n plus a naught. No matter what these coefficients are, it doesn't matter basically. These terms actually doesn't matter. It is interesting to prove this actually. I encourage students to prove this result. So once again I am telling you, if you have already proved it, fine, just go through it once again. Otherwise, I encourage you to prove it once. Alpha is the root of z power n is equal to 1, and let fx is equal to the polynomial an extra power of n plus an minus 1 extra power of n minus 1 plus so on up to a naught. Then sigma, the summation sigma k is equal to 1 to n, f of 1 by alpha power k is equal to n into a n plus a naught. So it doesn't matter what these terms are. So the result is interesting that way. So because of this will become n is 5 here. So this is 5 into, and leading coefficient is 7. Leading coefficient is 7. You can see the leading coefficient is 7 and the constant term is 2. So 7 plus 2. So the required answer is 9 into 5. So 45 is the required answer. Understanding could become better if you can prove this result once. All right. If z1 plus z2 is equal to 0 and z1, z2 plus z3, z4 is equal to 0, then z1, z2, z3, z4, what they become? All right. So it is given that z2 is equal to minus z1. So therefore, z1, z2 is also given z1, z2 plus z3, z4 is equal to 0. Since z2 is minus z1, so we have minus z1 square plus z3, z4 is equal to 0. So that means we have z1 square is equal to z3, z4. Now let us consider a cross ratio. This cross ratio you consider. So I am considering the cross ratio z1 minus z2 into z3 minus z4 by z1 minus z4 into z3 minus z2. Any cross ratio you can consider. Any cross ratio you can consider. See, Z1, Z2, Z3, Z4, cyclically they can be permuted in 4 minus 1 3 factorial ways, that is 6 ways. So, any of the 6 cross ratios you can consider. If any one cross ratio is real, all other cross ratios are also real. So, therefore, we shall see if this cross ratio is becoming real, in which case the points will become concyclic. So, here this can be written as Z1 Z2 is minus Z1 into Z3 minus Z4 by Z1 minus Z4 into Z3 minus Z2 is Z1 plus Z1. So, this I will write it as 2Z1 into Z3 minus Z4 by Z1 minus Z4 into Z3 plus Z1. So, this is 2Z1 Z3 minus 2Z1 Z4 by Z1 Z3 plus Z1 square minus Z3 Z4 minus Z1 Z4. All right. So, we have Z1 square is equal to Z3 Z4. Z1 square is equal to Z3 Z4, they get cancelled. So, what I get here is 2Z1 into Z3 minus Z4 by, if I take Z1 common here also, Z1 into Z3 minus Z4. Now, you can notice these two terms are getting cancelled, these two are also getting cancelled, you are getting a real number. So, therefore, a cross ratio is real. So, if a cross ratio is real, then the 4 points can be concyclic. So, concyclic means the 4 points can be, they can be like this, they can be like this, or they can even be like this. So, they can be like this or like this. So, you can choose both the options, be concyclic with the vertices of a cyclic quadrilateral. So, both of them can be taken, all right. So, both the options are correct here. Of course, you can't say anything about rhombus and trapezium here. I'll just have a little water. All right. So, next, all right. So, if alpha is equal to cos 2 pi by 21 plus I sin 2 pi by 21, then the value of a big summation kind of thing is given here. Alpha plus alpha square plus alpha power 4, all these things. You notice certain powers of alpha are missing, you can see. Alpha cube is missing, like alpha power 6, etc. Whatever the powers that are there, those numbers are less than 21 and prime to 21. Those numbers are less than 21 and prime to 21. All right. So, let us say, let this much, whose sum is to be found, we will call it as S. Whose sum is to be found, we shall call it as S. So, what I will do, S plus, okay, I will just write down the missing terms. Missing terms are 1 alpha square, alpha cube is missing, alpha power 4, alpha power 5, alpha power 6 is missing, alpha power 7 is missing, alpha power 8 is there, alpha power 9 is not there, alpha power 10, alpha power 11, alpha power 12 is not there, alpha power 13, 14 is missing, 15 is missing, 16 is there, 17 is there, 18 is not there, 19 is there, 20 is there, fine. So, this much. So, this is sum of all the roots, so which is 0. So, We shall write this as s plus 1 plus alpha cube, you see, 1 plus alpha cube plus alpha power 6 plus alpha power 9 plus alpha power 12 plus alpha power 15 plus alpha power 18. This much I will take in one bracket, and these terms alpha power 7 and here alpha power 14. We shall just put them separately. So this is equal to 0 anyway because sum of all the roots. We need s. So s plus, now this summation is 1 minus alpha cube to the power, see number of terms are 8. 7 by 1 minus alpha cube plus here I will write this as 1 plus alpha power 7 plus alpha power 14 minus 1 is equal to 0. All right. So this is, now 3 is not prime to 21. So therefore s is s plus 1 alpha power 21. So this becomes 0 plus alpha cube is not 0. So here 1 minus alpha power 7 whole cube by 1 minus alpha power 7 minus 1 is equal to 0. So therefore this is also 0. So you get s minus 1 is equal to 0 or s is equal to 1. So the required summation, the answer is 1. Quite a simple problem. All right. So let us move on to the next problem. The roots which are common to z cube plus 2z square plus 2z plus 1 and z power 1987 plus z power 101 plus 1 is equal to 0. All right. So this is z cube plus 1 plus 2z into z plus 1 is equal to 0. So we have z plus 1 into z square minus z plus 1 plus 2z into z plus 1 is equal to 0, right? So we have, you can take z plus 1 common, z plus 1 into z square minus z plus 2z becomes z plus 1 is equal to 0. So from this minus 1 is one root, here we get omega square, where omega is the complex cube root of unity. Now of this, now consider this equation, z power, consider this equation, z power 1987 plus z power 101 plus 1 is equal to 0. Obviously minus 1 is not a root here. So minus 1 is not a common root. If I put omega, which is a complex cube root of unity, and if I put omega, what happens is, so 1986 is divisible by 3. So therefore you get omega to the power of 1986 into omega, like that you get. So what you get is omega here. So I think I need not show this basically. So we can directly write omega here. Now here z power 99 into z square, this becomes omega power 99, this becomes 1, omega square will be there. So omega square plus 1, you see this becomes 0. So that means what? Omega is a root. Omega is a root. So now when omega is a root, omega square automatically will be a root. Why? Omega square automatically will be a root. Why? Because this is an equation. This equation has real coefficients. So complex root should occur in conjugate pairs. So the conjugate of omega is omega square. So therefore omega square automatically will be a root. We need not substitute and check. So omega and omega square are both the roots, the two roots. So the roots which are common to this, number of roots are 2 and the roots are omega and omega square. You can say the number of roots are 2, those roots are omega and omega square. We can now move on to the next problem. Alright, Z1 and Z2 are two distinct points in an organ plane. If A into mod Z1 is equal to B into mod Z2, where AB belongs to R, then the point AZ1 by BZ2 plus BZ2 by AZ1 lies where? Some line segment on the real axis, imaginary axis, etc. Alright, so here I will consider Z1 is equal to R into e to the power of I theta, and I will consider Z2 is equal to R1, R2 into why R1 and R2, mod Z1 only I will write. So mod Z1 into e power I theta, this is mod Z2 into e to the power of I theta plus alpha. So because you see here, it is given A mod Z1 is equal to B mod Z2. So we can consider Z1 is equal to mod Z1 e to the power of I theta, Z2 is equal to mod Z2 into e power I into theta plus alpha. Alright. So A into mod Z1 is equal to B into mod Z2. So from this, A into mod Z1 is Z1 into e power minus I theta. Mod Z1 is Z1 into e power minus I theta, and B into mod Z2 is Z2 into e power minus I theta plus alpha, right. So this is A Z1 e power minus I theta is equal to B Z2 e to the power of minus I theta into e to the power of minus I alpha. So these two get cancelled. So what you get here is you are asking about A into Z1 . So you have A into Z1 is equal to B into Z2 into e power minus I alpha. So what is then the point, this point, we are talking about this point. A Z1 by A Z1 by B Z2 plus B Z2 by A Z1. All right. So you have, from this we can write Z2 is equal to A by B Z1, Z2 is equal to A by B Z1 e power I alpha, right. So we can just do that. A Z1 by B into Z2 is A by B Z1 e power I alpha plus B Z2 is A by B Z1 e power I alpha by A Z1. All right. So this is, two things are getting cancelled. You get e to the power of minus I alpha plus here e power I alpha. So e power, if e power I alpha is what? Cos alpha plus I sin alpha. Here cos alpha minus I sin alpha. So what you get is 2 cos alpha. So basically what you are getting is one purely real number. So A Z1 by B Z2 plus B Z2 by A Z1 is purely a real number. Therefore it has to be on the real axis. So this imaginary axis, this circle, all that is not there. First option only. Now we just check minus 2 to plus 2 thing. See, 2 cos alpha anyway lies between minus 2 and plus 2. So this is lying on the real axis, and it's actually the locus is the line segment in the bounded closed interval minus 2 to plus 2. So therefore option A is correct. All right. All right. So let Z1, Z2, Z3, Z4 be vertices of a quadrilateral. Then this quadrilateral will become a square if, let us see these conditions, quite a direct problem. So let us say this is A Z1, B Z2, C Z3 and D Z4. All right. In the case of if it has to be a square, if it has to be a square, the diagonals have to bisect each other. So Z2 plus Z4 by Z2 plus Z4 by 2 is equal to Z1 plus Z3 by 2. So you have Z2 plus Z4 is equal to Z1 plus Z3. So this is Z1 minus Z4, Z1 minus Z4 is equal to Z2 minus Z3. So option A is correct. All right. Next, and of course, Z1 minus Z3 is equal to mod Z1 minus Z3 is equal to mod Z2 minus Z4. Diagonals are equal. The length of the diagonals are equal. Even this is correct. All right. Next, Z1 minus Z2 by Z3 minus Z4, is it real? All right. So Z3 minus Z4. All right. Argument of AB or BA, argument of BA is what? It is argument of Z1 minus Z2. Next, argument of DC is Z3 minus argument of Z3 minus Z4. So if they form a square, then these argument of Z1, these two should be parallel. So these two lines should be parallel. Therefore, this minus argument of Z1, Z3 minus Z4 is equal to 0. So that means argument of Z1 minus Z2 by Z3 minus Z4 is equal to 0. The argument of some complex number is 0 means the some complex number has to be purely real. So this implies this complex number Z1 minus Z2 by Z3 minus Z4 is purely real. All right. Next, this is correct. And then Z1 minus Z3 by Z2 minus Z4 is purely imaginary. Let us see that. So Z1 minus Z3. See, if it has to be a square, then they will be perpendicular to each other, the diagonals, and therefore argument of AC let's see A minus argument of Z2 minus Z4. So BD, this should be pi by 2. So therefore, this is argument of CA is argument of Z1 minus Z3 minus argument of Z2 minus Z4 is equal to pi by 2. So in other words, argument of Z1 minus Z3 by Z2 minus Z4 is equal to pi by 2. The argument of some complex number is pi by 2 means this complex number has to be purely real, purely imaginary, sorry. This complex number has to be purely imaginary. So therefore, all the 4 options will be correct if this quadrilateral becomes a square. All right. Let's move on to the next problem. PZ1 lies in a circle with OP as diameter, where O is the origin. Points Q and R are taken on the circle such that, okay, we'll first draw a circle. PZ1 lies in a circle with OP as diameter. All right. This is Z1. Okay. Points Q and R. Q is affixed by Z2 and R is affixed by Z3. Are taken on the circle such that angle POQ is theta and angle QOR is also theta. This is also theta. Then the ratio Z1 Z3 by Z2 square something. All right. We will use the rotation concept. So here the vector OP is rotated in the anticlockwise sense to make it coincide with OQ. So final position is OQ. So final position in the unimodular form is equal to initial position in the initial vector in the unimodular form into e power I theta. Right. Now OQ is Z2 is equal to mod OQ by mod OP. OP is Z1 into e power I theta. Here we have one more point. This is OP is the diameter, therefore this angle, so angle in a semicircle is a right angle. So this angle is 90 degrees, this angle is 90 degrees. So in the triangle OQP, we have cos theta is equal to, this OQ by OP, right? So OQ by OP is basically cos theta. So we can write Z2 is equal to cos theta into Z1 into e power I theta, let it be there like that. And we can also consider, we will rotate OP to make it coincide with OR. So final position is OR. So final vector in the unimodular form is equal to initial vector of the unimodular form into e power I 2 theta, because now theta plus theta, 2 theta. All right. So this is OR is Z3 is equal to OP is Z1 into OR by OP into e power I 2 theta. Now OR by OP, if I consider the triangle OPR, even this is a right angle triangle. So in this cos 2 theta, if I consider, if this is OR by OP. So OR by OP is now cos 2 theta. So Z3 is Z1 cos 2 theta into, let me write little more legibly, OP cos 2 theta into e power I into 2 theta, right? So this is Z3. So we have Z2 here and we have Z3 here. Now the ratio Z1 Z3 by Z2 square. The ratio Z1 Z3 by Z2 square, we will consider that. So that is Z1 Z2 Z3, sorry. Z1, Z3 by Z2 square, right? So this is Z1, Z3 is Z1 cos 2 theta e power I2 theta by Z2 square is cos square theta Z1 square e power I theta whole square e power I2 theta. So we can cancel Z1 square. Z1 square we can cancel, e power I2 theta is cancelled. What we are left with is cos 2 theta by cos square theta. Cos 2 theta by cos square theta. So option A is correct. Option A is correct. All right. Let us move on to the next problem. Okay. So then if argz lies between 0 to pi by 4, then the least value of root 2 into mod of 2z minus 4i. All right. So here this is the line y is equal to x. Why? Wherever z is, its argument has to be minimum 0, maximum pi by 4. So the slope of the line y is equal to x is 1. So therefore, argz means it has to, the region in which z lies should be in this region, in any of this, in this entire region, right? So this is how it should be. Now this is root 2 pull out to z minus 2i. All right. So what is this point here? 0, comma 2. So 0, comma 2 is here. So if you, the distance between 0, comma 2 to this, to z. So where z should be, so that this distance is least. Where z should be, so that this distance is least. So z has to be the foot of the perpendicular drawn from the point 0, comma 2, as simple as that. So therefore, so this is mod of x minus y is equal to 0, right? So it is 0 to by root of 1 square plus 1 square. So root 2. So you are getting root 2 here. So for this. So therefore, the minimum value of this you are getting it as root 2. So you already have root 2 into 2 into this root 2. Minimum value here is root 2. So the whole minimum value, required minimum value is 4 basically. So the required answer is 4. So the interpretation geometrically will save a lot of time and we can do it quite quickly. Which of the following is oblique or true for any complex number z? All right. Let z is equal to, let us say, x plus iy, and so that r into e to the power of I theta, that also we can write. So e power z mod. So this is conjugate of e power z, right? So z is x plus iy, its conjugate. So this is e power x into e power iy conjugate, which is e power x anyway is real, and conjugate of I is minus I into e to the power of minus iy. This becomes e power x minus iy. So x minus iy will be z bar. So e power z bar. So therefore e power z conjugate is e power z conjugate. So option A is correct. Next, option B. So here just write this as log z bar. It's not going up basically. So here the question is log z bar. So this is log r into e to the power of I theta, its conjugate. So this is log r plus log e power I theta. All right. Anyway, ln r is real. It will get out of the conjugate symbol. And here this is ln of e power I theta is basically I theta. Its conjugate is minus I theta. So minus I theta. Its conjugate is minus I theta. All right. So therefore, ln r plus ln e power minus I theta. So we can write this as ln r into e power minus I theta, which is nothing but ln of z bar. So even this is correct. All right. So the next one is cos z conjugate. Conjugate of cos z is cos of this some typographic. This is not going up actually. It is cos z bar. So this is, we can write cos z as e power I z plus e power minus I z by 2, right? We can write cos z plus I sin z plus cos z minus I sin z. So by 2. So we can write like this. So conjugate of this is the conjugate of this. So 1 by 2 into the conjugate of e power I z plus e power minus I z. So if I take the conjugate, I get what? Half e power, conjugate of I is minus I, conjugate of z is z bar, plus e to the power of, conjugate of minus I is I, conjugate of z is z bar. So what you are getting? This is nothing but half e power minus I z bar plus e power I z bar, which is nothing but cos, this is nothing but cos z bar, right? This is nothing but e power I theta plus e power minus I theta by 2, where theta is z bar. So therefore cos z bar. So even this is correct. Next, z1 power z2, that conjugate. Oh, I see. So z1 power z2 conjugate. We'll make one more. Okay. z1 to the power z2, the conjugate of this, we have to prove that this is equal to z1 conjugate to the power z2 conjugate. All right. E power z1 log z2. Shall I write like this? So I'll write like this, z1 power z2, I'll write like this, the conjugate of this. So this is e power z1 bar log z2 bar. So this is e power log z2 bar to the power, okay, just interchange this, z2 z1 here, Z2, Z1 here. So log Z1 power Z2 bar. So the power log something is that something. So this is Z1 bar to Z2 bar. So even this is correct. So therefore all the four statements are correct. All right. Next. Let Z1, Z2, Z3, Z4 be the roots of the equation. Z power 4 plus Z cube plus 2 is equal to 0. Then the value of pi r is equal to 1 to 4, 2 ZR plus 1. So that means we want 2 Z1 plus 1 into 2 Z2 plus 1 into 2 Z3 plus 1 into 2 Z4 plus 1. This is what we want. All right. The given equation is Z power 4 plus Z cube plus 2 is equal to 0. So for this equation, sum of the roots, which is Z1 plus Z2 plus Z3 plus Z4, this is sum of the roots, which is minus b by a, which is minus 1. Next is sum of the products taken two at a time, sigma Zi Zk, Zi Zj we can write. And that is 0 because Z square coefficient is 0, and taken 3 at a time is also 0. This is also 0, and minus, plus, minus, plus. So product of the roots, which is Z1, Z2, Z3, Z4 is equal to 2. So this is what you got. Just keep it aside, and then you just consider this product. This product is 2, 2, 2, 2. So 16 Z1, Z2, Z3, Z4, and all the other sum of the products taken 2 at a time, some of the products taken 3 at a time, all that will become 0 because of these two. But we have one case where 2 into Z1 plus Z2 plus Z3 plus Z4 that comes, and plus 1, 1, 1, 1 if this is multiplied, that comes. So we have 16 into this value is 2 plus 2 into sum of this is minus 1 and plus 1. So we have 32 minus 2 plus 1, 30 plus 1, 31. So the required answer is 31. Right? Next, if Z1, Z2, Z3 are the vertices of a triangle such that mod of Z1 minus Z2 is equal to mod of Z1 minus Z3, then the argument of 2Z1 minus Z2 minus Z3 by Z3 minus Z2. All right. So we shall consider a triangle. Z1, Z2, Z3 is the triangle that is to be considered here, and mod of Z1 minus Z2 is equal to mod of Z1 minus Z3. So that means what is given is these two sides are same. So therefore, these two angles are same basically. All right. So then argument of these things. All right. So what I will do, I will consider rotating BC to make it coincide with BA anti-clockwise sense. So final vector is BA. Final vector in the unimodular form is equal to initial vector is BC in the unimodular form into e to the power of I whatever theta. Let us call this as theta. So this is I theta. So BA, BC, there is no link. All right. So this is BA is Z1 minus Z2 by mod Z1 minus Z2 is equal to BC is Z3 minus Z2 by mod Z3 minus Z2 into e to the power of I theta, into e to the power of I theta. Let it remain like that. Now, or we can write Z1 minus Z2 by Z3 minus Z2 is equal to mod of Z1 minus Z2 by mod of Z3 minus Z2 into e to the power of I theta. Let us keep it like this. All right. So now, I will consider CB and CA, and CA I will rotate to make it coincide with CB. So final vector is CB. So CB by mod CB is equal to CA by mod CA into e power I theta. Direction is anticlockwise sense. So this becomes Z2 minus Z3 by mod Z2 minus Z3 is equal to Z1 minus Z3 by mod Z1 minus Z3 into e power I theta. So this becomes Z2 minus Z3 by Z1 minus Z3 is equal to mod Z2 minus Z3 by mod Z1 minus Z3 into e power I theta. Now let us look at what is required actually for us. For us, argument of this is required. So argument of what is required for us is argument of Z1 minus Z2 by Z3 minus Z2 plus Z1 minus Z3 by Z3 minus Z2. This is what we want. Okay. So this is argument of Z1 minus Z2 by Z3 minus Z2 is some scalar, some real number into e power I theta. Let that real number be some R1 into e power I theta plus Z1 minus Z3 by Z3 minus Z2. So you can see here Z2 minus Z3. So we get a negative sign here. So one thing is you get a negative sign here, and also e power minus I theta. So R2 into e power minus I theta. So that means what? You see Z1 minus Z2, Z1 minus Z3. All right. So the argument of these two complex numbers, the angle between them is what? So they are conjugate to each other, right? So therefore, plus or minus pi by 2 is the difference, is it not? So C is correct. All right. Next, let Z1, Z2, Z3 be three distinct complex numbers satisfying mod Z1 minus 1 is equal to mod Z2 minus 1 is equal to mod Z3 minus 1. And let A, B and C be the points represented in the organoid plane corresponding to Z1, Z2, Z3 respectively. Then Z1 plus Z2 plus Z3 is equal to 3 if the triangle ABC is what kind of triangle? All right. So here we have a triangle ABC, if Z1, Z2, Z3, they represent the vertices of this triangle. And there is a point 1, let us say, there is a point 1. Now it is given distance from Z1 to 1, that is mod Z1 minus 1, is equal to distance from Z2 to 1, that is mod Z2 minus 1, and distance from Z3 to 1, that is mod Z3 minus 1. These three are same. So obviously 1 is the circumcenter of ABC. All right. Now, then Z1 plus Z2 plus Z3 is equal to 3. See, if Z1 plus Z2 plus Z3, if 1 is also equal to, this much, then 1 is centroid also, right? So if that happens, 1 is the circumcenter and 1 is also the point, 1 is also a centroid, also the centroid, then the triangle has to be equilateral triangle, nothing else. So straight, right? So now let us see the next problem. The area of the triangle whose vertices are the roots of z cube plus iz square plus 2i is equal to 0. By trial and error, let us see if I is a root. If I put I get I cube plus 2i, which is minus I plus 2i and 0. So therefore, I is a root. So we will find the other roots. So z cube coefficient is 1, z square coefficient is I, and z coefficient is 0, constant term is 2i. So we have found z is equal to I is one root. We will factorize this. 1, this is I, 2i square is minus 2. So I get minus 2 minus 2i. So this becomes 0. So what I am getting here is z square plus 2iz minus 2 is equal to 0. So z is a quadratic. So z is equal to with real coefficients. No, not real coefficients. It's a quadratic. Z is equal to minus b plus or minus root of b square, 4i square. 4i square is minus 4 minus 4ac by 2a. So this is becoming 0. So what happened? Z square plus 2iz minus 2 is equal to 0. B square 4i square minus 4a4. Okay, I made a mistake here. Just a second. Yeah. So minus 2i plus or minus root of b square, which is 4i square, which is minus 4 minus 4a c is minus 2 by 2a. So this is minus 2i plus or minus root of here 8 plus 4. Sorry, 8 minus 4. You get 4 here by 2. All right. So this is minus I plus or minus 1, right? So the other roots are I is one root, right? 1 plus 1 minus I is one root, minus 1 minus I is one another root. So area of the triangle is half of, you see here 0, 1, 1, 1 minus 1, 1, minus 1, minus 1, 1. So how much this happens? Half into minus 1 plus 1, minus 1 plus 1, gone. Minus 1 into, what you get here? 1 plus 1 plus 1 into minus 1 minus 1. So this being area, we can consider the absolute value. The absolute value minus 2 minus 2 minus 4 by 2 is minus 2. So absolute value is 2 square units. So the area of the triangle whose vertices are the roots of this, that area is 2 square units. All right. If 1, z1, z2, etc., zn minus 1 be the nth roots of unity and omega be a non-real complex cube root of unity, then the continued product omega minus zr. So the continued product R is equal to 1 to n minus 1 omega minus ZR. So this is omega minus Z1 into omega minus Z2, so on omega minus Zn minus 1, right? So this continued product is what is required for us. Okay. So now extra power of n minus 1 by x minus 1, if I consider, this is x minus Z1, x minus Z2, etc. x minus Zn minus 1. So if I put x is equal to omega in this, omega power n minus 1 by omega minus 1 is omega minus Z1 into omega minus Z2, so on omega minus Zn minus 1. All right. Now here, now what happens to this? If n is equal to 3k, is a multiple of 3, then of course this will become 0. This will become 0. And if n is equal to 3k plus 1, if n is equal to 3k plus 1, what you get is omega minus 1 by omega minus 1, which will become 1. And if n is equal to 3k plus 2, we get omega square minus 1 by omega minus 1, which will become 1 omega plus 1. So this value you get 1 plus omega or omega plus 1 you can write. All right. So this is it. I think we have reached the end of it. All the very best for your preparation for the upcoming JEE main exam and also the JEE advanced exam. Thank you.